and welcome to this new video. I'm Elias, and I'm going to be explaining the difference between a vortex generator and a wing fence. As you probably already know what a vortex generator is. This is for a video for people taking an aerodynamics exam or airplane structure exam. As on my exam last semester, I had a question about these, and I definitely had it wrong because our syllabus doesn't mention them. So how can you know what it is? Well, I'm going to be explaining to you right now. I must say I'm retaking the exam tomorrow, so I don't know if you have to take advice from me, but I'm pretty sure I'm right about this. So, first of all, a wingtip fence, a wing fence, as we can see here, wing fence is a vertical plate in the middle of the wing or at the wingtip. That's why I'm sometimes saying wingtip fence. So vertical plate, that's an important thing to remember because we're going to look at what's the difference between a vortex generator, because I answered vortex generator when they asked this on the exam. So a vortex generator is placed at an angle. Now I'm drawing them very weird. Most of the time they're very calculated and efficient, but this is probably not going to work well in real life. But you get the concept. You have smooth air coming in on the wing, and then we make turbulent flow because of the vortex generators. Why is that a handy thing to do? It's because turbulent flow has more energy, so sometimes for control surfaces or other usages, it's handy to make turbulent flow so you have more energy in your flow. So that's why we would use vortex generators. Vortex generator. Now, we're going to look at a wingtip fence. It's definitely not a vortex generator. If you look at what vortex generators are, they would be these little plates on the side of the aircraft, definitely not one big plate, or like we see here, also very different from a vortex generator. That's the citation excellence, I think. Now, first of all, I have to explain wingtip vortices. So what happens on the wing is that you have span-wise flow and also stream-wise flow. Now, the streamwise flow is what you've probably already learned of, and it's what we're manipulating here when using these vortex generators. Now, spanwise flow is when air travels over the wing, and then at the end, at the wingtip, especially, that's where it's the biggest of a problem, is when our lower pressure on the top of the wing, which is the main thing that creates our lift, meets our higher pressure. And the higher pressure, of course, directly wants to go to lower pressure. And we get this big part of induced drag, like this spiral we can see here. And that's a big problem. I think when the Falcon 20 was made, the engineers didn't think that much about it because it wasn't that much of a worry back then. But now we want our aircraft to be as efficient as possible. So what is one of the solutions to that? It's a wing tip, like this one. It's actually a little wing we place at the end of the bigger wing, and the little wing actually has the same problem, but because it's a little wing, it causes way less induced drag. And our big problem here is solved and turned into a way smaller problem. It can actually save 5% to 10% if it's done very well, and that's a lot of fuel and a lot of money. So it's important on new aircraft. Now, back to the wingtip fence. I'm also first explaining all of this so you get the wingtip fence at the end. The wing fence. The wing fence is not about making the aircraft more efficient, but it's about making the characteristics better. It's about making sure our aircraft stalls at a higher angle of attack, so you can actually do more with the aircraft. Now, higher angle of attack, I'll write that down because it's important to remember it's actually the whole point of this thing. What happens with these wing fences is, I'm going to draw an elliptical wing again. I know the Falcon 20 does not have an elliptical wing, but it's just so easy. Now, we have our fence here. We have the streamwise flow we can see here, but then also the spanwise flow. And what it does is it blocks the spanwise flow. So it actually makes sure that at our wingtip, the difference is not as much as with this, but not for efficiency, but purely to make sure we have better streamwise flow at the end of our wing, and our wing will stall at a higher angle of attack. So we can actually fly with a lower streamwise flow than we would need without these wing fences. It's not something utilized on newer aircraft, but on these older private jets, you can see it very frequently. I think some older airliners also had it. So that's my short explanation, just so you can answer the question on your exam. If you want like a very detailed explanation, I'm not yet the guy to ask that. I hope one day I'll know this stuff better and I can explain that to you. But you can go onto Reddit and there's like an engineering page that explains wing fences very well. So I would highly advise that. Maybe I'll put it in the description. And good luck with your exams and bye.